Hi guys, we're just going to cover a vertical example in work and energy. We have covered a horizontal example in work and energy, so if you haven't covered that already, it's probably good to cover that before we get into this, because this is a little more complex, because we have two unknowns. So this is another way of solving if you have two unknowns. Basically, when we use the potential energy formula, we know it's only going to be used for height, whereas when we use the kinetic energy formula, we're going to be actually using that for speed, because it has velocity in it. The best way to actually learn this is by example. So we're going to work a problem, okay? Our example is a 70-kilogram person jumps with a speed of 6 meters per second upward. How high can he leap? Now, without actually doing a double take, we actually see that we're only given two pieces of information to actually solve for the height. Now, notice what I said. Height. What does that mean? We're going to be using that potential energy formula very soon. So, first, we always need to draw a diagram, as you can see here, and we need to start identifying values. For example, velocity, we need to be able to also identify our mass, our height, and we always need to remember gravitational force, because usually before you ever work out a problem, it's good to always write out your formula. So first you draw a diagram, write out your information, write out your formula, make sure all your positive and negative signs are in its place. It's going to help you down the road quite a bit, because most times when you get excited and you're near the answer, you're going to forget those. So mass is equal to 70. Velocity, we know, is 6 meters per second upwards, so that means the top, or the apex at which he reaches, has got to be 0, and where he started was 6, because he jumped 6 meters per second upwards. We know that his mass is 70 kilograms. We know that we don't have his height, and we know that the gravitational force due to acceleration is negative 9.8 meters per second squared. But in this case, we're just going to leave it at negative 9.8 because this is the speed at the top of the leap. So let me scroll down here. Since basically height is asked for, we are going to use the potential energy formula. You need to remember that potential energy is equal to mass times gravitational force due to acceleration times the height. But we don't have potential energy, so we can't find the height. So when we basically have two or more unknowns, we're going to use this formula right here. Basically, this is going to solve for your top, and this is going to solve for your bottom. So this is at the top, or the apex of his jump, and this is at the bottom, basically right down here. So we're going to write this out. Potential energy means height is involved, and kinetic energy means that speed is involved, and you can tell that both are involved because speed, 6 meters per second upwards, and we're looking for his height. So this is going to be used every time there's a mention of speed and height. Okay, so I guess I'll just read this out, but this basically gives you a pretty good idea. When you're looking through this formula, you're always going to ask yourself, well, is height involved? Because potential energy has to do with height. So we're going to say yes, because that's what we're looking for. So you don't cross this out. But then, and remember, okay, so we're looking at the top, so you look at potential energy, and you'll be thinking about only the top. When he reaches the apex of his leap, does he have some sort of potential energy? So that means, does he have some height at the top of his leap? Yes, he does. So you do not cross it out. When it comes to kinetic energy, does he have any speed at the top of his leap? No, because the velocity at the top of his leap is 0. So we do cross it out, and we put a 0 through it because it will not count. Now we're going to look at the bottom of his leap, right down here. So does he have any potential energy at the bottom of his leap? No, he doesn't have any potential energy at the bottom of his leap. 0. Does he have any kinetic energy at the bottom of his leap? Yes, he does have speed. He doesn't have height, that's why we crossed out the potential energy, but he does have speed at the bottom of his leap. It's 6 meters per second. That is your kinetic energy. So now that you have a good idea of setting up your top and your bottom, all we're going to do is, what you have left over is PE is equal to KE, which is potential energy is equal to kinetic energy. So we're going to take the potential energy formula and put it on this side, which is mass times the gravitational force due to acceleration times your height is equal to your kinetic energy, right? And notice that your kinetic energy, all you're doing is substituting the formula in again. And you got to know the formula for kinetic energy is half times mass times velocity squared. So we're going to set both of these equal to, because that's all we're left with. On potential energy left on this side, kinetic energy left on this side. So we're going to set these formulas equal to each other. Then we can see that the masses will cancel out. So we can cancel the masses, and we're left with gravitational force due to acceleration times height equals half times velocity squared. All we have to do now is substitute in our values. We know that 9.8 is our gravitational force due to acceleration. We do not know our height because that's what we're looking for. It's equal to 0.5 times our velocity, which was 6.6 meters per second squared, which is our speed slash velocity. And then we just solve. We divide by 9.8 on both sides, and we get our height as 1.82. Remember your units, it's going to be meters. So I'd just like to put a quick note in here that we would have done the same procedure if they wanted speed. In that case, we would have went up to the kinetic energy formula first, but if we had more than one unknown, we would do the same setup. So you don't really need to worry about that, but you always are going to use the same setup when they want or when they mention speed and height. So I hope this helps you with this problem. If you have any questions, make sure you post it in the forum, and you can ask for another video. I'd be happy to set it up. Have a great day, and happy studying.